put up some videos this week to help review for the final. And so your job is to take notes along the way. So one of the first things that we did was we added and subtracted integers. Okay, so adding and subtracting integers. And remember that when we talk about integers, we're talking about both positive and negative numbers. Okay, so if you remember, we have that little chart that we do, and we say we have counting numbers. And counting numbers are like 1, 2, 3, on and on. And then next we have whole numbers. And whole numbers are the counting numbers plus 0. Okay, but look, they're all positives. And then next we have our integers. And this is what we're dealing with primarily in algebra, right? Or with this concept is integers. And this is going to mean all of your negative numbers, like -3, -2, -1, -20, okay? All the way up to your positives, to positive infinity. Now, this does not include fractions and rational numbers, right, which are our fractions, because we're only talking about integers in this piece. The next set of numbers, which you do have to work with rational numbers or with fractions, but in this test piece, they weren't checking on it. So rational numbers are all your fractions. Okay, and they could be all kinds of fractions. And if you remember, fractions are actually decimals. So like this fraction, 2/3, is really 0.66 repeating. And so rational numbers are those repeating and terminating decimals. Okay, meaning like 1/4 is 0.25. It terminates, it stops. But 2/3 is 0.66, which is a repeating number. And then, of course, we have that little subgroup way out off to the right, off to the outside, which are our irrational numbers. And our irrational numbers are like the root of 2 or 3.14, on and on and on, because pi is a non-terminating, non-repeating number. Okay, so when we added and subtracted fractions, we were looking, or added and subtracted integers, we were looking at things like -19 plus 31. And you combine, we used GEMDAS, you have to combine. If the signs are different, a negative and a positive, then you're really doing subtraction. You're really doing 31 minus 19, and you're getting 12. But 12 is positive 12 because this number, absolute value, is greater than this number's, okay? Or this number appears, this number here appears to be bigger than this number. So our answer is a positive 12, okay? But we also learned that you, if your signs are the same, you're adding, except that when you have that subtraction sign, and every time you see a subtraction sign, you're supposed to be saying adding the opposite. And now you end up with that positive 12 again, because this minus a negative 31, what it was originally, is the same exact problem as plus 31. Okay? But if we had a negative 19 minus a 31, and you change to addition and change your power, now your signs are both negative, and so you're actually adding. So you're saying 31 plus 19, and you're getting 50. And 50 is your answer, but it's negative because both the signs are negative. Okay, and then our next component that we worked with were the multiplying and dividing of integers. And we had the simple rules of if you're multiplying a positive times a positive, you get a positive answer. If you multiply a negative times a negative, you get a positive answer. So essentially, when you're multiplying and dividing, if your signs are the same, you're going to get a positive answer. But if you do a positive times a negative or a negative times a positive, you're going to end up with a negative answer. And so if you have negative 10 times a positive 2, you're going to end up with a negative 20, because a negative, sorry, let me find a different color, a negative times that positive gives us a negative, which is what our answer is over here. Okay? Or if I have a negative 2 times a negative 3, I'm going to get a positive 6 because a negative times a negative gives me a positive. Okay, and those were our multiplying and dividing integers. Then we talked about the properties, and we had lots of properties that we talked about. You have your cheat sheets. I would go over them. You're going to have to be able to give examples as well as tell what properties they were. So we had an example might be, give an example of the commutative property of addition. So I want an example of the commutative property of addition. So you have to write something that shows me the commutative property of addition. So you might write 2 plus 4. I shouldn't have put parentheses. 2 plus 4 plus 8 is equal to 8 plus 2 plus 4. And basically this 8 commuted to this side because the rule of the commutative property of addition says you can add the numbers in any order. As long as you're adding, you can add them in any order. Whereas the commutative property of multiplication would look like 2 times 4 times x is equal to x times 2 times 4. Okay? Or you could say 2 times 4 times x is equal to 4x times 2. Same thing. The numbers are commuting around. And again, there's no parentheses. That's how you tell the difference most of the time between associative and commutative properties. Of course, they did give us tricks like this. And if you take a look at this problem that I just wrote, the 3 is the same. It's in the same place. But these numbers traded spots. And they commuted around. And so even though there's parentheses here, this is the commutative property of addition because what's inside those parentheses is what did the commuting. If you want to see the associative property of addition, you would do something like 2 plus 3 plus 5 is equal to 5 plus 3 plus 2. And your parentheses change spots. The numbers that you add together change spots. Usually this would be like this, where the parentheses change spots. But it could be something like this as well. Okay? Then they gave you samples. And they said, all right, here's a problem. 3x minus 4 minus 2x is equal to 3x minus 4 plus 2x. And so you have to think, what did they do? What did they do that made the difference? Okay, so what is the answer to this problem? Well, this one has parentheses and this one doesn't. So everything's in the same order. So it doesn't look like any order changed and the parentheses didn't change. So I'm going to eliminate association and commutative right off the bat. But in order to get rid of these parentheses, this negative would have had to be distributed. So if they distributed, then the negative 1 would get multiplied times the 4 and give you a negative 4. And the negative 1 would get multiplied by the negative 2x and give you a positive 2x, which is what this is. So this is actually an example of the distribution property. Okay? Now, the next things that we talked about were converting numbers or converting, writing equations from algebra wording, algebraic equations, okay? So they would give us things like the sum of 3 times a number and 9 is 76. And we had to write the algebra expression. We had to turn it into a math problem. So the sum is my first keyword, and it means something to do with addition. So I'm going to say, all right, what did I add? Well, I added 3 times a number. Well, what does 3 times a number look like? 3 times a number looks like 3x. And that's where that plus sign comes in, 9. And so the other thing I added was 9. Is means equals, and 76 is our answer. And so this is the answer to converting it from words to algebra expression. Now, they did this a lot with us, and we practiced this for several weeks because our word problems are now things like the length is 3 less than 4 times the width. And I have to say, this is the one that gets you guys every time. This 3 less than, okay? This piece is huge. And so you have to remember that 3 less, you're going to say, okay, if I have 5, what's 3 less than 5? Well, 3 less than 5 is 2. That means you took 5 minus 3. So when you do this, you're going to have to say that the length is equal to 3 less than. And the subtraction of the 3 is after. You have to figure out what the first number is. So 4 times the width is over here. And so my 4 of my width is here. And 3 less than 4 of my width means take the width and subtract 3 from it. Okay? And so using those words and reading them carefully, and I have to tell you, this one, the less than, most of you write it as minus 3 plus 4w. Or you do 3 minus 4w. And although this one works out algebraically as correct, it should be written like this. But this is what most of you are writing, and it's wrong. Okay, so you have to remember to convert them correctly. The next thing that they added to us was using, now remember, you have to go over all your properties, so check your book for all the properties that you need to know. And then the next thing that they introduced to us was using those problems and using word problems. And so they gave us the formula distance equals rate times time. We have used perimeter formulas. And so if you're doing the perimeter of like a quadrilateral, you're going to do side 1 plus side 2 plus side 3 plus side 4. If you're doing the perimeter of a triangle, you're talking about 3 sides added together. Okay, we've done volume. Volume is length times width times height. So these are kind of all the basic formulas that you're supposed to remember. Area of a quadrilateral is going to be length times width. Okay, so make sure that you always write your formula first and then plug in your information. So if you take a look back at this problem that we did here, if you're actually having to solve for it and solve for the perimeter or the width of something, they usually are going to give you the perimeter amount or the area amount. So if they went on to say the area is equal to 81, then you have to write your formula that you know. So you had to solve for length, and that had to be one piece to it. But area of a rectangle is going to be length times width. And now your area is 81, so you can plug it in. And your length is that 4w minus 3. And now you have to multiply it times your width, which we don't know yet. Okay, and so to solve this, you're going to distribute this w to both pieces. And you get 4w squared minus 3w. Okay, and I shouldn't have chosen area because it's not something that we've covered yet. Mostly we've covered perimeter. Okay, so I'm not going to take it any further, but I want you to see that you write your original equation, then you plug in the pieces that you know, then you solve for your variable that you're looking for.